All right, well, I think we're going to get started here. We've got about 100 people on right now. We have many more who have registered who I think are going to join as we move along. Just to let all of you know who are on the webinar right now, thank you for joining us. This webinar is being recorded, which you should see at the top of your screen, your Zoom screen. Please give us your patience today. This is our first time ever doing a webinar. We've been using Zoom for our individual conference calls for our committee, but first time with a webinar, so we hope it works out okay. I want to thank you all for being here. Thank particularly our panelists for agreeing to participate today for the 7th Vanitec Energy Storage Committee meeting. As you know, this was originally scheduled to be held in person together in Dusseldorf in conjunction with the International Flow Battery Forum, and we have Anthony Price on the webinar today. Welcome, Anthony. Unfortunately, due to the current situation in the world, we're going to do this remotely. We hope it works out fine, and perhaps this will be a forum for us to do some future events as well. So thank you for joining. I want to just briefly start, though, with a couple of housekeeping items. The first of which is this is the registration that went out, and in the bottom right-hand corner, you see the agenda for today. We're going to start off with an overview, both of Vanitec and our Energy Storage Committee. And we'll have an update on the market from Terry Perlis. Our friends at Australian Vanadium have put together a presentation on the reuse and recycling of vanadium electrolyte. And then we have a VRFB marketing update for you. After this webinar ends at 10 o'clock US Eastern, approximately 2 hours from now, we have a separate call for VRFB developers. That's by invitation only. If you have been invited to that and you have not yet registered, please do so. That'll take place immediately after this ends. If we end early, it will start on the hour at 10 o'clock Eastern US, 1600 Central European time, and 2200 in China. So please, if you have not registered for that yet and you got the invite, please register there. This is the Vanitec antitrust policy, which we need to take care of today. I'm going to summarize it a bit for you, though. Presentations and remarks today on pricing will only relate to historical pricing. The data that's been presented will be sufficiently aggregated to meet US and EU antitrust safe harbor guidelines or is publicly available. No discussions here today will take place on the effect of historical data on current or future prices. No agreements will be made to adopt uniform pricing, leasing conditions, or fees for services. And information on proprietary aspects of a company's technology related to vanadium batteries will not be shared. Technological standards will not be used to exclude competitors. Please keep that in mind as you ask questions today, and I asked all of our panelists to keep those guidelines in mind as well. Another quick housekeeping item, we are encouraging questions. I'm going to try to monitor the Q&A function in here. I'm not going to be monitoring the chat room. I see people are already chatting in there, welcoming each other. If you have a question, please use it in the Q&A function on Zoom. Time permitting, I will address those questions to the panelists at the end of their topic. If we don't have time, we will try to address those afterwards in writing to share with everyone after the webinar. Note that, again, the webinar is being recorded. It will be available on the Vanitec website under our VRFB tab after the webinar ends. I just want to give a quick update on Vanitec. I am John Hilbert, the CEO of Vanitec. Our job is to expand markets for vanadium and promote a stronger industry. We are the only not-for-profit global member organization promoting vanadium. Our members benefit for our work in technical areas, on market development, health and safety issues, and a forum to collaborate and understand and promote the uses of vanadium at a global level. You may have seen these at some of our past meetings. Just want to give you an idea of who our members are. These are the members in the Americas, in Australia, Asia, in China, and in Europe, Russia, and in South Africa. We operate in 3 main committees. This one, obviously, you're aware of today because you're joining us, our Energy Storage Committee, which you'll hear more about in a bit. We have a Market Development Committee, which works on other activities to promote vanadium and undertake steel research in new and emerging technologies. Our statistics program on the monthly and quarterly consumption and production of vanadium. We also have a very active Health, Safety, and Environment Committee. We have scientists and consultants from around the world helping us out to deal with things like the REACH regulations in Europe, other health and safety issues that come up around the globe, as well as we undertake some of our own research. And then finally, we have our administrative team in the UK. Just a bit about joining Vanitec. We have two types of membership. One is for those who are producers of vanadium. Those dues are per calendar year and based on their amount of production or conversion of vanadium. If you are a producer or converter, you have to be a full member of Vanitec. And again, those dues are based on your levels. We do have a second level of membership, associate members, for those who do not currently produce or convert or meet the bylaw, but still meet bylaw criteria. Associate member dues are $10,000 per year if you intend to produce or convert vanadium in the future, and $5,000 per year if you do not intend, but you are somehow still involved in the vanadium industry, either as a manufacturer, electrolyte manufacturer, research institute. For those who are in that category of having been involved in the VRFB, we do have a separate membership category for the Energy Storage Committee. It gives you access to all of our meetings, gives you access to our stats, gives you access to Energy Storage Committee, and we have an introductory first-year fee of half price, $2,500 for VRFB companies. So if you're interested in joining Vanitec, please let me know. You've got my contact information. I'll be happy to talk with you about joining Vanitec. I'm going to turn it over now to the chairman of the Vanitec Energy Storage Committee, Mikhail Nikimorov from Bushveld Energy, who's going to give you a couple more slides here and introduce our next speaker. So I'm going to turn this over to Mikhail to get started. Go ahead, Mikhail.
Thanks, John. So hopefully everybody can see me now, also socially distanced like everybody else. Thanks for that introduction, John. I guess the first question, especially folks who have not yet seen or been to our previous presentations, and I think one of the benefits of this virtual setup is the ability to kind of reach a broader audience. So the question is, well, why does a group of an association of vanadium producers even have an energy storage committee? And that really boils down to the potential impact that energy storage has on vanadium demand. So this is a slide from a report by the World Bank group that had just come out actually earlier this year, and it talks about the minerals that are impacted or potentially impacted by demand from energy storage. And as you can see, whereas a couple of the maybe the ones at the top are quite familiar to folks, especially if they're following kind of lithium technologies. Vanadium is number 5 in terms of the mineral that is going to be most impacted by the energy transition and the movement from fossil fuels to clean energy, and the need for storage that comes along with kind of the redesign of the entire energy landscape that we are part of, and it's basically a kind of a fait accompli at this point. And so that creates a massive opportunity for the vanadium producers. But at the same time, there are some challenges that come with that. And if I can get pages to move correctly, I'll explain to you how that works. Okay. So we, So we talked about the opportunity for vanadium. The challenge is that of all the technologies kind of in any state of commercial or pre-commercial deployment, you can see that the vanadium redox flow batteries all the way on the right in terms of how important the chemical contribution is of the materials to the technology itself. And it is by far the most significant one. And obviously some of these minerals are commodities, so the value on one day or another will change. So this is just information out of one report out of from ARENA, the International Renewable Energy Alliance. But what you can see is it's because you're all the way on the right, that does create some challenges. The interesting thing is it also creates some opportunities, and really what Vanitec is here to do through the Energy Storage Committee is to engage with the part of the sector that is the energy storage sector at the moment, that is the vanadium redox flow battery. Although you could envision other other technologies that use vanadium in storage as well. It's just none of them are kind of that massive uplift opportunity or in terms of their status of commercialability. So this challenge is well known. It is something that I think any kind of battery company gets asked after an initial phase of due diligence. And it's something where really collaboration between different participants in the value chain become quite important. And it's also why a number of initiatives that the Energy Storage Committee has been looking at in terms of electrolyte, in terms of vanadium electrolyte leasing or renting that we've talked about, and also some of the other topics that you will hear later today. They really come from the fact that it's both a massive opportunity, but at the same time a fairly unique challenge that may not be as an extreme challenge to some of the other technologies. So with these two kind of factors in mind, both in 2016, the Energy Storage Committee was set up by Vanitec. You saw that there's already a couple of other committees that existed prior to that. And I think it highlights the importance of this industry and this potential path to more demand and use for vanadium. And really that's the purpose of the ESC is to drive that and to focus on that in the energy storage market. We tend to have one in-person meeting, which this is kind of replacing, usually on the Monday before the Flow Battery Forum, which is coming over in the next couple of days, also virtually. But it's been kind of a good structure for us. It is for an opportunity for us to engage with the market and with a broader audience. It has always been free, whereas our sessions that are tied to the rest of the organization, usually in April and October, are closed. So this is kind of a unique form of that, and we've had quite a bit of success with it. So we're very keen to continue. It's been a good opportunity to talk about the market and other things going on in energy storage. So this is our first virtual version, and John said to please bear with us for any technical challenges. But we think it's a it might be something that we think about further because a lot of the content that is shared now we can actually store and then can be replayed by people later on. So it doesn't have to only be live. I think the other great benefit is a lot of travel was needed to go to where where the forums were located, usually in Europe. So this creates an opportunity to have a lot broader access, and I can just see from the participants number that we're probably at twice where we were last year, even though we in person the attendees the numbers were actually quite good. What we're going to do though is have a more compact session today. And really just cover only three topics besides this intro. So one is we'll have an update on the vanadium market, which I think is very important for people to understand. The second is we'll get an update on something that came out of one of the battery breakout sessions that we did at the end of the session last year. And that's around, can we create some sort of a white paper from the industry on the fact that the electrolyte is reusable from a sustainability point of view and how that process might work. And then the third part is, one of our major initiatives out of the ESC was to market the technology and see how we can elevate the information about the technology, about the companies, and that solution, and expand it beyond just some press articles, but also talk about and use social media, the different channels that are available. Please keep this session as interactive. So if you do have questions for anything you see, just write them down Q&A, and John has said, he will answer. And we, after each of the three presenters, there will be actually an opportunity to answer those questions as well. We want to keep it interactive, so I think a little bit harder virtually, but that is definitely one of the priorities. Page. So the interesting thing is about this year to date. So 2020, I think for all of humanity has been challenging and difficult in ways that we probably didn't expect. The interesting thing is for me as kind of both a participant in the sector and an all-looker from the side is that the momentum for vanadium redox flow batteries seems to be unaffected by the situation. And there's been a few interesting announcements and developments. Recently I read in kind of the vanadium weekly, actually daily update ferroalunite that Shanghai Electric is moving forward with another one of these large, maybe they're called pilots in China, 100 megawatt batteries a pilot there. But with another one of these, we know that there's a system under construction in Dalian, and there was another one in Hubei. And so this is interesting to see a third very large technology. I think a lot of times the news out of China doesn't make it to some of the English language press, but nonetheless, that was an interesting development. Certainly what did make it to the English language press was the joint venture to build a facility, not necessarily a battery, but a manufacturing facility in Saudi, kind of maybe a second gigafactory for flow batteries. That was outside of what is already in China. So that's an interesting development. And really, I think the first time we're seeing a lot of this large scale movement outside of Japan and China in terms of the technology. So that's quite positive. There's been a lot of M&A activity on batteries in general, and I think that the VRFB has not been immune to that, which is good. We could see that through Invinity, which is an ESC member. So we're happy to kind of mention them as well. But I think that was a very successful merger of two existing VRFB companies in different locations, and I think that's also kind of maybe foretelling of how the industry is maturing when you actually have M&A activities between two players. And also recently we saw an example of Enel, developing a project, and that's a very large global utility, and IPP. EDF is also involved in another project that uses VRFB technology in the UK. So we're seeing some of these larger global players getting into the tech, using the tech, which is quite nice. So it's not only, I think, just a question of what's going on in Japan, what's going on in China. We're seeing a lot more traction, especially this year, in other parts of the world, and that's quite exciting because, well, we're only in June, so a lot more is yet to come. So I think with that, we still remain very positive as to what this year will bring for the technology and for vanadium, and that's quite exciting because it could have been a very negative story. So with that, I'd like to kind of introduce our first speaker and hand over to.
We do have one question for you already.
Already? Okay.
Yes.
Wow. Please
explain in more detail the statement that vanadium's relative contribution will only increase.
So the logic of that statement is if you think about the battery, it has, and I'll talk a little bit maybe more about it. So I'm not trying to advertise for my short presentation later this week at the Flow Battery Forum. But if you think about the components of a battery, it has certain parts that are commodity components, like a mineral such as vanadium, and it has other components that are manufacturing that can be improved through R&D, through economies of scale, through better supply chain management. And what you see over time, and we've seen this in lithium as well, is that the other components can become cheaper, through working practices and scale and things like that. And so the cost of a solution can come down, but there's a theoretical floor that it has, which is the raw material costs. The stuff that is bought on the market and can't become cheaper because it's a function of supply and demand and just a market-based economy. So when these other components that are really around doing things better come down, the component that is a commodity does not change unless there's an R&D to replace that commodity. So if you assume that you will need the same amount of vanadium, and you can decrease the costs of the other components through better manufacturing and purchasing power and things like that, then the percentage that the vanadium contributes will grow. So as the battery becomes cheaper, the percentage of the piece that is a commodity will relatively increase. In absolute dollar numbers, it will not, but as a percentage, it will become larger as the cost of the overall system comes down.
All right, thanks.
Can I now introduce Terry?
Yes, go ahead, introduce Terry. I'll give Terry controls while you're doing that.
Terry, you're introduced. So with the exception of last year, we've always been privileged to have Terry Pearls talk through the vanadium market. And I think now he's got even more hats that he wears. I think in this capacity he's here kind of representing GDP squared. But if you ever want to understand what's going on in the vanadium market, Terry should be your first point of call or port of call. I don't think that anybody has kind of more relationships and understanding from, I think, the bottom up of what's going on. And certainly when you want to talk about the market, he's the person to lead with. So we're thrilled to have him here. Terry, I'm handing it over to you.
Thank you, Mikhail and John. It's great to see so many people here for this webinar. This technology for me is quite interesting. I've been following since 1991 when Dr. Maria published her first patents. And I really do feel like we're at a point where we're seeing the confluence of the maturation of this technology and the growth of a actual market, particularly longer duration grid level market, where these machines are going to be quite applicable. So it seems like a very interesting time right now. I just, maybe one comment on the points Mikhail just made. I agree with what you've said. I think there is some opportunity and some work out there right now to increase the utility of the vanadium in the system. I think typically we talk about 20 pounds of V2O5 per kilowatt hour of storage capacity. And I think there's some work going on to maybe drive that number down a bit. So there's some chance that the relative importance of vanadium costs can change going forward. But that's not what I'm here for. I'm going to talk a little bit about the market. Please do feel free to reach out to me. My email address is in here. I'll be happy to talk or email and try and share any alleged knowledge I might have about this market. Okay. Whoops. Okay, we're going to go through these slides here fairly quickly. This first slide is just showing the historical V2O5 price on a daily basis in China on the right and in Europe on the left. And you see a very similar pattern here. Sorry, I don't know. I've got a bit of a delay here, I think, John.
There you go.
Okay, so you see a very similar pattern here. What's noticeable is the fact that the prices in China at the peak in November surpassed the peak prices in the West. And as we sit here today, we're in an environment where the Chinese price is more than 30% above the Western price. So that's an interesting picture. And if I can get to the next slide here. This shows the long-term relationship between prices in China and in Europe. And what's really interesting is if you look at the first part of this graph, typically you see the Western price or the metal bulletin price slightly above the Chinese price. And this makes sense because historically China is a fairly significant net exporter of vanadium. And so the price of vanadium in the Western world is driven by the availability and price of Chinese exports. But what you see in the second part of this graph, during this peak, we see the Chinese prices predominantly above the Western prices. And I think this is an interesting dynamic we'll talk about more in a bit. We're going to just look at a couple more slides here, drilling down on this, this information. I can't seem to move the slides, John. I don't know.
That's fine. I'll do it, Terry. Just tell me when you want me to advance and I'll do it.
Okay, great. So this is that same curve, just looking at the back end of the curve, and you can see how the Chinese price has more or less been leading the Western price. And I think it's all about what's going on in terms of consumption. If we can go to the next one, John. Here's the long-term historical price in the West. I think this is interesting. Obviously, you see a very erratic pattern here with occasional price spikes and some periods of very low prices. So we've got a market that fundamentally is unstable. And if you look at the statistics there, what that data shows you is where the price has been over the last 16 or so years. So I think that's important data to keep in mind. The next slide, we'll look at the same data, but on a distribution chart basis. And what this clearly shows is the peak of that normal or almost normal distribution is somewhere around $6 per pound of V2O5. And if you look back in time, that's the most, the price that's typically there more often than not. I think it's an important price because it tells you something about the cost of production in a normal market, that the price is going to reflect the cash costs of those last units required to satiate demand. And I think that that's a pretty good indicator of where that number is normally. But there's also, interestingly enough, a second peak that you see somewhere around $14 or $15. And I do believe what this is demonstrating is that in a very tight market where supply is struggling to keep up with demand, there is support for prices at these levels. When we see prices go to the ridiculous levels we saw in 2018, that's just not sustainable. In the long run, you're going to see massive loss of demand due to substitution and bring in all sorts of new production. Vanadium is not a rare element. It's, depending on who you believe, the 17th to the 20th most abundant element in the Earth's crust. It's just rare to find it in economically viable concentrations. And when we see ridiculous prices, of course, all these things become economical. So the important thing is that that price level, $14 to $15 per pound of V2O5, which typically would be about $60 per kilo of V as ferrovanadium, we don't see a lot of substitutional loss of demand. Remember, 90% of the demand for vanadium is in the steel industry. And to the extent that price can be accepted by the steel industry, there is stability at that level when we have a very tight market. Next slide, please. Okay, let's go into some data here on production and consumption. This is data from Vanitec, and what we see is production and consumption data on a quarterly basis, and we can see these numbers marching up significantly over this period. And I think it's entirely to do with the new rebar standard in China driving increased demand and therefore increased supply of vanadium. I'm still struggling a bit to understand why fourth quarter of 2019 we saw both production and consumption going down, but there's clearly a upward trend in the production and consumption of vanadium in China. Next slide, please. This chart's just looking at the price, how the price has come down over the last 2 years. We've seen some moderate increase in Chinese production over this period. But I think what we're showing here is the fact that in the short term, 1 or 2 years, there's just not much new capacity that can come on in China. But what's interesting, the production seems to have been continuing here even during prices reaching a relatively weak level. Next slide, please. So in China, vanadium production and consumption grew at a very high rate over the last couple of years. In China now, what we're seeing is steel production has surged and is now above where it was pre-COVID. And so what we're seeing is the consumption of vanadium is continuing to grow, but I would suspect that the supply of vanadium is unable to grow really from where it's at now, and there's some news suggesting it's going to fall back a bit in China. Next slide, please. Here is the picture outside of China of production and consumption, and what you see is these lines are reversed from the Chinese side. In China, production almost always exceeds consumption, and there's material available for export. What this chart shows you is that outside of China, consumption is above production, and we need somewhere on the order of 8,000 to 10,000 tons of pure vanadium a year exported from China to keep the Western markets in balance. The other thing you'll see here is that consumption outside of China has actually decreased over this period, and that's a reflection of the loss of demand due to high prices. In the West, there's applications in the steel industry where If you've got the right mill and the right metallurgist, you can change from vanadium to niobium. And in some of those applications, you can get to the strength level you need with half as much niobium as vanadium. It's very different than the Chinese rebar application, where the vanadium and niobium content of the steels are very, very similar. So the dynamics are different. We saw the price spike in 2018. In some of these applications, people moved to niobium, and still today, even with the markets are where they're at now, there's no incentive for those people to come back to vanadium. So we've seen some loss of market share there, and it's typical. We see it every 7 or 8 years when we have one of these price spikes. Next slide, please. So as we said, the consumption has decreased due to higher substitution due to higher prices. We've seen some very minor changes in supply in the Western world here in the first quarter. Just looking at data, so there's some minor decrease in supply in the first quarter, but really not much change on the production side. And I think the consumption side remains quite weak outside of China. Next slide, please. Okay, let's look at some steel data, because again, 90% of the vanadium is going into steel. So steel production is a very, very good proxy for vanadium consumption on a global basis. Next slide, please. This is really quite disturbing. What you see here is the monthly steel production in China and the rest of the world. And again, you see in China, this dip in production in the first quarter due to the virus, and where they're at now, they've come storming back and are actually producing steel at the highest levels I think they ever have. What's really concerning is ex-China. You see how production of steel just dropped off the table in April. It came back slightly in May, but I think we still have a very weak environment out there. And what happens outside of China in terms of steel production is going to be important to determine what vanadium consumption will be going forward. Next, please. Okay, this is the same data. Really what we're showing here is that the steel production, again, in China has increased. Outside of China, it's been decreasing. Next slide, please. So if we look outside of China, we saw a 24% decrease in steel production in May 2020 versus a year earlier. If we presume that that steel production level continues, there's no recovery in steel production ex-China, we're going to see a decrease in demand of about 11,400 metric tons of V versus our perspective before this virus hit. So it's a huge factor on vanadium consumption. I would suggest that we're going to see some improvement. How fast and how much, I don't know, but I think we will see some recovery of steel production outside of China. So this is kind of a severe case. Next slide, please. So when we looked at this market before the COVID, we came to the conclusion that outside of China, we had a shortfall of about 10,600 tons of V. Production was going to be 10,600 metric tons of V less than consumption. If we see steel production outside of China continue at the May level, which again I think is an extremely drastic assumption, we're going to see that demand ex-China drop by about 11,400 tons of V this year. We also see a decrease this year of at least 1,000 tons of V in demand in the titanium industry as a result of the virus. So when you roll that all up, what it would suggest is that the Western markets will have close to 2,000 tons of vanadium above consumption that could be exported to China. And I guess the point here is that the availability and price of Chinese exports or the demand for Chinese imports is going to be a major driver in this market as we go forward. I think it's all, as usual with everything, every metal, it's all about China. Next slide, please. So here's the data looking at China imports and exports. And what's really interesting is you see over 2019, the level of exports dropping and imports, which historically don't really exist in China, surging. And of course, in the first quarter, imports decreased, exports increased a bit as the COVID virus was affecting the situation. But I still think there's a very interesting trend here. I just got the May data in here as well. And what you'll see in the May data is that imports were just about the same as April, just over 100 tons of V, and exports were about 400 tons of V. So they're down to the lowest level they've been in recent months. And if we go to the next slide, we'll roll this up and just look at net exports that we're at in China. And what's occurred, you see that by December of last year, China became a net importer. And I think what we're seeing is broader adaptation of the new standard for rebar in China is driving consumption up. And I think production in China has obviously grown tremendously over the last couple of years, but the growth seems to have come to a halt. If we look at April or May data, which is not on this chart yet, you'll see the net exports just about 300 metric tons of V. So what happens here, I think, is paramount to what's going to happen to the vanadium price in the Western world. We've got weak demand, how quickly that comes back, and does China need imports or do they have material available for export? Those are going to be the major drivers. And next, John. That's it for me. Again, if anybody has any questions or comments or just a good joke or want to chat, please send me an email or give me a call. I'm happy to talk about vanadium anytime.
Terry,
John, I'll send it back to you.
We have one question already in the question and answer room, and if others have questions, please type them in now. And just remember, any questions you ask need to be about historical issues. So Terry, this one is historical. Please keep your answer historical. Did Corona affect the vanadium prices in April and May of 2020?
Yeah, I don't know if we want to go back up to the one of the earlier slides, John, with the price history and. Okay, so what this chart's going to show you is that the vanadium price actually was rising in the first quarter. And if you look at all the metals in the world, and noble metals in particular, it's really interesting. Vanadium prices in general are up 7 or 8% in the first quarter versus late last year. So I think what we've seen is in the first quarter, we've seen demand in China, the bottom fell out and then it came back very quickly. And in the West, the demand decreased and it hasn't come back. But the confluence of all those issues, really you see some relative strength in the vanadium market, even in light of the impact on steel production, both in China and outside of China early in 2020.
All right, thank you, Terry. Next question, Terry, what is your view as to Chinese stock levels?
I believe that stocks are extremely tight right now in China. You know, you have several major producers of V2O5 that are co-product producers. These are steel companies that generate vanadium slag and process that slag into V2O5. And I think the situation in China is that the supply of oxide is restricted. There's not a lot of ability for production to surge in the short term. The steel mills are operating at capacity and generating as much slag as they can. And the alloy producers, ferrovanadium and VCN alloy, which are the alloys consumed by the steel industry, are pulling more material. So in China, the monthly sales of material really are, it's a kind of a monthly auction. And what we see is a growing consumption from those steel mills, pulling VCN and ferrovanadium and creating a very tight market for V2O5. So I think, I've got data. I can go back and look at production of VCN and ferrovanadium and V2O5, and I can show you a very scary curve that would suggest inventories of V2O5 have plummeted by several thousand tons over the last year or two. And I think what we've seen is any excess inventory that built up after the price spike and the market more or less collapsed. I think the inventory that accumulated there has been cleaned out. So I don't have the sense that there's a lot of inventory out
there. Thanks. Terry, next question is about this graph that's up right now. The graph shows only 1 month where China was the net importer of vanadium. What informs the hypothesis that China has become the net importer? I think that's just I think you would just say that's the first month where it happened, but that's their question.
Yeah, so if you look back in time, the first quarter of 2004, China was a net importer of vanadium, and you saw the price spike of 2004, 2005 follow thereafter. If you look at this data through December, there's clearly a trend, and then things change. Why things change? Well, I think it's clearly a result of COVID, and obviously today, April data, May data, we can't say that China's a net importer of vanadium. The question is, are we going to return to the trend that we saw late last year here in the coming months as Chinese steel production has taken off and vanadium consumption is growing due to the increased adaptation of the standard? I think in China, vanadium consumption is growing at more than 20% a year right now.
All right. Next one, Terry, and this is asking about the cost of production. If you could maybe talk about these in relative terms, not in absolute cost dollars. What is the cost of production of each type of source? The slag or spent catalyst, and then the FEV basis or V2O5 basis?
So you really have three important sources of raw material in the vanadium world. About 70% of vanadium production is utilizing vanadium-bearing slag generated at steel mills in Russia and China and one steel mill in New Zealand. In these steel mills, there is a cost to the steel mill to generate this slag. They have obviously some capital investment in the melt shop to allow them to drive the vanadium into the slag before they start the calcium additions in the steelmaking process. But from an operating standpoint, they have to blow a few thousand cubic meters of oxygen through the metal. They've got some labor, and they'll lose some iron to the slag when they generate this slag. So there is a cash cost associated with generating the slag, and then there's obviously a cost of converting that slag to V2O5. If we look at primary vanadium mines, it's somewhat similar situation. Same ore, we're just going through a different process to extract the vanadium and not the iron. And again, you've got a mining cost and a refining cost. And the third leg is the secondary guys, vanadium coming out of the ground in oil that ends up either in spent catalyst, resid upgrading catalyst, or it ends up in ashes or boiler slags resulting from burning vanadium-bearing oils. And typically those materials are bought and sold at some percentage of the vanadium market, and then there's a cost to convert those materials to vanadium. So you can envision this third leg of the industry having kind of a cost for raw material that typically moves with the market. And the other two legs of this market having relatively fixed costs that don't change with the market. I think if you want to know, what the cost curve looks like and what those cash costs of those last incremental units required to meet the market demand are, you can go back and look at that price distribution chart, and I think that tells you a lot.
Thanks. Question for Terry. If vanadium is taken as a whole, the balance of supply and demand in China seems to be critical. Are there different aspects of balance across the different vanadium products? For example, FeV, V2O5, nitrides, etc.
So in China, the major application for vanadium is in concrete reinforcing bars, steel bars used in concrete construction. And for various technical reasons, VCN is the perfect fit for that application. So what you see in China is at least 60, maybe 70% of the consumption of vanadium by the steel mills occurs as VCN alloy. Outside of China, it's a much smaller percentage, and the vast majority of consumption is as ferrovanadium. So again, you've got different dynamics in different markets. And again, vanadium market is driven, you've got to go back to the oxide basis. And there's more capacity than you can shake a stick at to convert oxide to ferrovanadium or VCN. So the production and the cost and the price of vanadium is really driven by the availability of economically viable raw materials. I don't know if that answers the question or not.
Well, I think they were asking, is there a different supply demand equations in different formats, not just in China, that are driving the prices in those areas?
Again, I think in the West we have in North America we have a significant demand in the titanium industry, but we still probably 85% of demand in North America is in the steel industry. The same's true in Europe and the rest of the Western world. So, the dynamics are all, it's a global market for V2O5. There's barriers to entry in some markets. In the US, we have import duties, dumping duties on ferrovanadium coming from China and from South Africa. So that is a bit of a barrier. We've obviously got some trade war duties between the US and China that are impacting the trade both ways. But other than those issues, again, it's a global market, and it's all driven by availability of oxide.
All right, I think we have time for just a couple more questions here. One is, Terry, can you touch on vanadium demand and premium in the chemicals market?
Sorry, vanadium demand in the chemical markets?
Demand and premium in the chemicals market.
Yeah, so vanadium, in round numbers, about 5% of the vanadium consumed in the world goes into, quote, chemical applications. And those applications include oxidation catalysts, for example, catalysts for production of sulfuric acid, maleic anhydride, phthalic anhydride, pollution control catalysts, NOx and SOx abatement catalysts. They're used as corrosion inhibitors in petrochemical plants, gas absorption systems, frits and colors for ceramics. There's a litany of applications for vanadium in the chemical industry. And in some cases, they require extremely high purity oxide or downstream chemicals. In other cases, the purity requirements are not so significant. So the growth in consumption is not huge. Most of these applications are mature, so we see growth similar to global GDP growth. There's always new things coming out. There's a lot of exciting things, John, that you're aware of going on in terms of research for new applications for vanadium. But if we look at existing applications, you've got a fairly stable market growing at global GDP, and the premiums for higher quality materials really run a spectrum based on what the specific requirements are. If the chemistry requirements are very strict, then they're going to be quite high. If they're not, they're going to be quite low. So there's not one answer. There's kind of a continuum there of price premiums for higher grade materials. When we talk about vanadium in general, we're talking about commodity grade, 98% pure V2O5 flakes. And if we want to go above that, then we start talking about special products and special price regimes.
Great. And then one final question, and then there are some more that are in here that I will share with Terry afterwards. And to the extent he can answer some of these, we'll get those out to you. Terry, sorry, I'm new to this commodity. Is there a price difference between metallic vanadium for the steel industry and V2O5?
Yeah, so the steel industry consumes, outside of China, primarily ferrovanadium, and inside of China, primarily vanadium carbonitride. And those products are produced with vanadium oxide. So there's formulas you can use to convert typically how the V2O5 price relates to ferrovanadium and VCN. So there's a very, very strong relationship there. The oxide is converted to the alloy through a carbothermic or aluminothermic reduction process. So there's costs associated with that. There's some yield loss. And if you do the math, you'll see if you take the vanadium oxide cost per pound of vanadium contained in the oxide, divide it by the yield, and add a recovery cost, you can calculate the ferrovanadium price. So if you go back and look at those indexes, typically the arbitrage between those indexes reflects the cash cost of conversion and the loss of recovery.
Great, thank you, Terry. Appreciate that. And Terry's going to be on here throughout this webinar. And again, there are some questions here. There are a couple that asked about future prices that I've told you we just can't answer those. There's a couple other here that, if possible, we'll have him answer those after the meeting today. So thank you very much, Terry. Appreciate it. All right, we're going to move on now to Vincent and Todd from Australian Vanadium to give us an update on some of the work we've been doing at Vanitec on recycling of vanadium electrolytes and the value analysis. I'm going to give control of the screen here to Vincent so he can move himself forward. Oops. Okay. And one second here. Okay, Vincent, you should have the ability to control the screen now.
Hey, Vincent, I think you're on mute.
Sorry, I'll unmute the microphone and start again. Thanks, Terry, for that lead-in on that first presentation, and thanks, John. Thank you for all attending. So what we're going to do today, this is a question that came up in last year's meeting in Lyon, where a lot of the vanadium flow battery producers wanted to know about vanadium as vanadium electrolyte as a recyclable opportunity, and what it means for the industry. How do we value this very important part of the vanadium battery cycle? In the introduction that Mikhail gave, he pointed out the importance of the size and the fraction that vanadium holds compared to other battery types, and that a very useful chart that he put up earlier in his presentation saying that vanadium redox flow batteries have a significant component. And this has led to a number of different ideas, some of which lead directly from this and are related directly to this discussion. So what we were asked to do, actually this paper originally started with Daniel Harris and actually Terry Perlis put quite a lot of input into it. Todd and I have just taken a bit of it on and extended it. And I think this body of work is not quite complete, and we value the input that it takes from here. But we just wanted to outline a basic framework for what we're doing going forward here. So let me see if I can just click on that, John, and make it go forward. Yep, hold on, one back. I think I've stopped one, that's right. There's a few slides here on the vanadium market, but we don't need to spend some time on them because basically Terry's just done that for us. And I know looking at his numbers, I'm probably a few points out one way or the other, given that we used earlier numbers. But basically, we saw a big input effect on the vanadium energy storage market during that price spike, and this of 2018. And that's really an impediment to the impact of the vanadium battery in the marketplace, something that we really would like to get around and try and overcome in future production. But one of the questions that was raised last year was, how do we value the vanadium in the battery now and in the future? And if we can't do anything with that material, how are we going to value it? How are we going to get it out at the end of the day? So what we've done is, in order to value it, the easiest way to look at it is to take the material in the battery and look at what you might do with that material. Now we mentioned it's a large volume of the battery. It's in a liquid form. It's an electrolyte. It contains a lot of vanadium. So really, what we want to be doing is taking that back into first principles as vanadium and what its value is to somebody. And that's really the thought process we follow here. It is worth noting, though, that in terms of production of electrolyte quality vanadium, there are only a small volume of number of producers around the world that can currently produce the volumes that are required for the flow battery industry. And I think this is a bit of a misconception out there in the marketplace that everyone can produce battery-grade electrolyte vanadium pentoxide. That's not necessarily the case. as Terry mentioned a few minutes ago, product grade that goes into the steel industry is not necessarily the same as the high purity application. And we know from our discussions with flow battery makers is that they're demanding a fairly high standard and high quality that's going into the applications. So I think I've gone back one, two more. Sorry, Terry. Sorry, John, can I go back one there? Have you still got control? Or we'll have to go back? Okay, thank you very much. Again, I'm not going to spend too much time on this. Terry said a lot of the things that are here, and some of these numbers were slightly different. But importantly, if vanadium demand goes up to deal with flow battery markets as they get very much larger, we're going to have to bring new production online. And getting to our real point of our presentation here is that for batteries to reach the level of magnitude of taking, as shown in the slide, if we're going to reach those levels of production and consumption of vanadium in the batteries, we're going to have to work out there's going to be a significant volume of vanadium available to be either recycled or used elsewhere. I'm just going to skip through this slide because it's something that's already been said. It's where prices are made available. And just getting to pricing. So we looked at this from a view of, sorry, I've gone back. So I'm in Australia for all those people online and probably suffering from a little bit of distance lag. When we look at the pricing of historical pricing of vanadium, that price again, this is an issue for all vanadium flow battery producers. And that the purity levels that are demanded for flow batteries is significantly higher than what is just commodity grade. And the idea that vanadium that is in a battery, we're calling it spent electrolyte. It's not really spent. It has all its vanadium still available to it. Is often can be considered as a secondary source of vanadium for producers. And the value of electrolyte needs to be converted, determined as its conversion cost to be a viable vanadium source. So we want to work our way through that now with you. Sorry, I've gone back. There we go. We want to bring up the idea that the best application for vanadium electrolyte is to use it in the battery in another battery application. So if you can imagine that we've got a vanadium battery out in the field, the business itself is no longer viable. So the battery, it's not that the battery doesn't work, the battery is now needs to be moved to another place. The best thing to do is to take that entire battery and its electrolyte and move it to a new location. Now, if the battery is at its full life of the run, say 20 years, maybe the battery itself, the physics of the physicalness or the physical components of the battery may be themselves past their lifetime. The vanadium itself will still be available in its full form to be used. So the best application we can say from this is to actually, the cheapest application is to take this material and reuse it in a vanadium flow battery application. This will require a minimum of processing and the filtration of the solution, the topping up of the acid consumption, of the acid concentration to make it a viable source is a key factor of that. So there is always going to be a cost, and a lot of what Todd's going to talk about in a few minutes is the cost of doing this, and not only with inside a battery, but also if we take it back to primary vanadium value. Remembering what the question a lot of was asked of us last year was, what is the value of the vanadium in the battery at any given time? Once it's been put into the flow battery and it's been operating for a significant period of time, how do we value the material that's in that battery? And that has to be the value that it has on the market price, less the cost of putting it into some other form. So we know that because vanadium electrolyte contains a lot of vanadium in solution, it can be introduced into existing refining processes and converted back to commodity grade electrolyte at a relatively low cost and a relatively high yield. I'm going to click to the next slide, and at this point I'm going to hand over to my colleague Todd Richardson. Todd's the Chief Operating Officer of Australian Vanadium and works with me here in Australia, and I'll take you through the next few slides describing the process that we might follow to get this vanadium back into its primary form.
Thanks, Vincent. Hi, everybody. Yeah, I think, like what Vince said, I think our goal here is just to understand what is the value of the vanadium in there, and if we had to reprocess that material for whatever reason, how much would it cost for us to do so? I think that'll help the supply chain for the vanadium redox batteries. It'll help battery producers understand a little more about, financing options, and there's a lot of implications here as to, what you can do with this vanadium if for some reason you have to recycle it somehow. So like Vince said, the first option I think is to look at, we need to understand a little bit about, how vanadium battery fails, what's the mode of failure. But, the first option is always to try to recycle that material into an existing vanadium battery. The second option could be something like ion exchange or something to clean out any impurities that you might have gained in this battery over the years or something. But so the worst case scenario, I think, is if you look at this material and you have to extract the vanadium units out of this electrolyte, so there's not really much value left in it as far as an electrolyte. And then you have to look at existing processes that are out there and try to understand what the cost would be to convert this material into a sellable product. So I think if you look at it from that angle, I think there's a few things that any vanadium producer would look at if they were going to purchase this material. And the first thing is, how does it fit into our process, and would it make sense to buy this material back? And what kind of value would it be for them? So that's really what the project is about. So I think if you look at most vanadium producers that use a hydrometallurgical process, and there's quite a few of you guys, I think you can see there's some advantages to this material. It's high in the vanadium grade is high. It's a high purity material, so it does hold some value. And if you look at the process that you use to extract the vanadium, it's not too much different than the processes that we're already using in vanadium production facilities around the world. So there's really two steps to this process, and that would be to extract this material. There's a few steps. First, you extract the material, and then you have to ship it somewhere up to a vanadium producer. So there's a logistics cost involved, which is not insignificant because it's a low grade vanadium. I mean, it's a vanadium solution, so the logistics costs are going to be, fairly high. It's not like shipping V2O5 oxide, for instance. So there's that, and then you have to look at, okay, what do you have to do to process this material to get it into a vanadium facility as a feedstock? So in order to do that, you're going to have to oxidize the vanadium, and then you're going to have to probably neutralize, depending upon the process, you'll probably have to neutralize the solution in order to make it a viable feedstock. Can we go to the next slide? So if you look at just published data, I think you can make an estimate about how much it costs the industry as far as reagent, labor, and energy costs. Let's go back one, sorry. So you can make an estimate as to what it would cost a typical vanadium producer. This could be a primary vanadium producer. This could be somebody who's producing vanadium from slags, as Terry mentioned earlier. That's a big section of vanadium production. But a lot of these things have some similarities, and part of that is conversion from a vanadium solution into a vanadium powder, right? So you can figure out that. And on average, I think it's fair to say somewhere around $1 a pound V2O5. The other thing that you have to take into consideration is the typical content of leachate. In most vanadium production facilities, you'll be limited if the vanadium grade is not high enough, right? So it would add some production costs if the vanadium grade was lower than your typical leachate processing. But this material is not. It's higher than the typical vanadium producer's leachate, so that's a positive for it as well. And I think if you look at the overall leaching, this is pretty standard published data as well. You can convert it to V2O5 flake, typically around 95% conversion, so you get relatively high conversion rates as well. Of course, you will lose some things. What that doesn't take into account is the oxidation and the additional caustic, and there might be some recovery losses there as well. We didn't take into consideration, but it's a high it's a high yield recovery process. So next slide. So I think the next step for us, really, for Vanitec, I think, in order to get just some good back of the envelope calculations to really understand exactly what this material is valued at, is to do a little bit of laboratory work. It won't require too much, but if we can get some electrolyte, we can do some testing, determine how much reagent usage is necessary to oxidize the material, how much is necessary to neutralize it, and we could look at different scenarios. This is just one of many pathways, but I think it's a first pass, and it makes a lot of sense on a first pass basis. There's always other ways to skin the cat, but I think this is a pretty typical process. There is some differences between generation 1 and generation 3 electrolytes, obviously, so you have to look at that as well. But I think the vanadium grades are fairly similar, and I think the process will be very similar as well. So what we're going to do in the next few months as a group here, with some help, we're going to put together our thoughts on the electrolyte and include the composition and preparation availability. We could use some help from the battery manufacturers and the users of vanadium to understand really modes of failure and how they would see this work. But I think that this is a good first step. And then describe the reuse of the vanadium electrolyte in the battery in 3 different scenarios: filtering, cleaning, and then purification, as well as actually having to redissolve it and reprecipitate it. So that's really next steps for us. If we look at the next slide. So I think I mentioned this just a little bit earlier, but there's obviously other technological solutions. I'm not saying this is the only one. There are some things that we could look at as far as like IX, other extraction technologies, so that you wouldn't have to spend as much on reagents, and you may not even have to spend as much on logistics and things. But again, you have to really understand the typical mode of failure, and a lot of these vanadium batteries haven't operated long enough for us to really understand what the modes of failure are, which is probably a good thing. That says that the technology is pretty good. So again, this is just some detailed work, but that we need to do in order to understand the cost, the kinetics of oxidation. And one of the things you have to do is make sure that in order to get good recovery, that all your vanadium is +5. And if your battery fails or something happens, you're going to have a lot of vanadium that's not in the +5 state. So you're going to have to spend some money to get it there. All that being said, I think there's some broad assumptions we can make with some of the information that we already have. I think we've talked about this slide, but let's see. I think the assumption is provided the electrolyte producer could provide it as a reasonable cost for a long-term supply agreement if you understand exactly what the salvage value of the vanadium is at the end of the life, for instance. Logistics costs are a big question. And there's some things that we can do to look at and delve into that a little deeper as well. Next slide. So really, this is the nuts and bolts of it. If you look at the 3rd bullet point here, I think this will give you an idea for how you would value something like this, or how a typical vanadium producer would value something like this. So, as a vanadium producer, you take a look at, okay, what can we sell it for? So the market value, and this, if you assume in this instance is $8 a pound, there's going to be some margin involved for that conversion, and then there's logistics costs. And I think broadly, generally speaking, you could ship this material probably anywhere in the world for about $1 a pound. And then and conversion, I think at the plant itself is going to be about $1 a pound as well. So the only unknowns really is just how much it costs for this pre-treatment, which will be oxidation, and then neutralization, right, step. So you can drive that pretty quickly and pretty simply, and we can make some broad assumptions about that even before we do any of the work. Next slide. So as I mentioned, the market price, you can make your assumptions on that. The margin, logistics costs, pre-treatment costs, and the conversion cost to convert this material back to a V2O5 is all part of the factors. And then the yield, there's really two yields. It's the yield from the producer itself, and then actually the yield for converting it to something that they can use. So those are all of the things that you have to define a little bit better, but we do have some ideas about it. So I think if you can't recycle the material as electrolyte and you have to use it as incremental production, the value of the electrolyte would be no more than the cost of getting the material processed, right, to the stage where they can sell it, the stage where they can precipitate vanadium from it. So I think a worst case scenario, if you're a battery producer or if you're somebody who's going to buy this vanadium to put in the battery, I think you can recognize it, depending on what your price assumption is and depending on what you think your logistics costs are. But worst case, I think is, there's a value of at least $1.50 to up to $3 a pound of V2O5 contained in there. And again, we'll have some better ideas about this, but I think that that's a generally conservative, realistic number. So what that means for the people here in this group, I think, is that there is an inherent value in that vanadium even after the battery's been, serviced full life. So there is a good salvage value for that vanadium, and it will hold its value for as long as that battery is installed, which I think is probably critical for doing your analysis for vanadium redox flow batteries versus other technologies as well. So Vince, I don't know if you want to jump in on this and talk about it.
Yeah, I think, thanks, Todd. John, can I have that back?
Yep. Which slide do you want? Next slide?
No, leave it there. It's fine. That was good enough. Just go back one. Yeah, just in summary, I think Todd's outlined the thought process that is there. I think we need a little bit more work on experimental work on those unknown X and Y values. What it means is we can get to and I invite everyone to look at that paper and take that formula out and get a view on it. Talk to your nearest vanadium producer as well to get a fair understanding of that. But those numbers are probably going to be around those numbers that you see. But you can basically say the value of the vanadium that's in the battery will have a positive value at the end. So it'll be that value that you buy it for, less the market value minus those costs at the end. So the fact that it has a positive outcome, a positive economic value, and this was a question raised by the vanadium flow battery producers. We need to know, they wanted to know that they can go off from a finance point of view and other points of view and say there is residual value, positive value in the battery of the vanadium. That's really important because it's a big differentiator for vanadium redox flow batteries around the world. It's very difficult to say if you're a lithium ion producer and using lithium ion batteries that you can say that value of those cells, once they've been fully used, can actually have a fixed value that you can calculate back out, because the cost of removing and stripping out and recovering the lithium and the other metals from those systems is not straightforward. Whereas in this case, it still involves a number of steps, but it is far more straightforward than in other batteries. And because of Mikhail's original statement that we've got a much bigger component of the battery in that metal, we can really say we can go down this sustainability or reusability step and put vanadium flow batteries in a unique space. So we'll expand on this by filling out the gaps, if you like, and then providing that in a more technical paper so that the vanadium flow battery users and promoters around the world have got something to base on. I think it does lead into the discussion about leasing, which is not being discussed here today, but the fact that there's a residual economic value that is calculable and can be shown for a specific case and for the general case is a very, very useful concept around the leasing value and for people who want to be involved in leasing. And leasing, as we know, is a key component for the delivery of medium and large scale flow batteries. So we want to be able to utilize this. Hopefully Vanitec can add on to the work we've done so far, make it a bit more clear and specific, and we invite input from all the flow battery producers around that. The last slide here, just rounding it, who can do this work. This is pretty much a who's who list on who can do things around the world. All of these companies, as far as I know, and all the countries involved, are very interested in vanadium energy storage market growth, and that's really epitomized by the effort that they've all put into the Energy Storage Committee in Vanitec, and how Vanitec itself has taken this on as a growth market, and why we think it's so important, not only from the future of vanadium point of view, but because of its sustainability and its use in renewable energy and the impacts that has on the world itself. So thank you for your time. John's going to ask possibly a few questions here.
We've got about 6 minutes here. For those of you who maybe missed the beginning of the webinar, if you have questions, please click on the Q&A function in Zoom to ask them, not in chat. We're not going to be inviting others to speak here. Just put your questions in the Q&A and we'll get to those that we can. So a couple of them here already, Vince and Todd. Let me pull them up here. First one that came in order was, are there currently any research projects about recycling of electrolyte, publicly funded or not, and where does the used electrolyte come from?
There's none that I'm aware of.
None that I'm aware of either.
All right. Next one, reuse in another system. Will the state of charge have an impact?
Yeah, I tried to allude to that, but yeah, definitely. If all the vanadium is in a +5 valence state, it's already oxidized. You save money on reagents. If the vanadium is, +3, +4, then most of these producers that you see on this list, and probably some others out there that can do the same thing. This is not, the only producers who can do it, but they're going to have to spend some money on an oxidizer, whether it be hydrogen peroxide or sodium hypochlorite or something to oxidize the vanadium before they can extract it, because they won't get good recoveries otherwise. So yeah, it definitely matters.
Thanks. I think this next one's for you again, Todd. For the recycling, was both chloride and sulfite-based electrolyte considered? Yeah,
so the difference in the Gen 1 and the Gen 3, I think the Gen 3 has got chlorides in it as well as the sulfates, which would also have an impact on probably the CapEx, if nothing else, for how you would do this process. I think it would be a similar process. I think you'd have to take into account materials of construction, because chlorides are a little bit trickier to deal with than sulfates, but yeah, it can be done in a similar process.
The last question was explaining the difference between Gen 1 and Gen 3.
Well, I'm not an expert here, but I do know that the chemistries are fairly similar. The vanadium concentration is a bit different in the Gen 3, and they use chloride solution, so it's a vanadyl sulfate mixed with a vanadyl chloride solution in Gen 3. Gen 1 is typically just vanadyl sulfate.
Great. Any other questions for our friends at Australian Vanadium? All right, then I'm going to move on.
Thank you.
Thanks, guys. I'm going to turn over remote control to Suella at LIFA Communications for our next presentation on our marketing campaign. So Suella, please take it over.
Thank you for the introduction, John. As John has introduced me, I am part of the team at LIFA Communications, and we have been advising and supporting the Energy Storage Committee on marketing the VRFB. Our presentation today is going to be a bit interactive. In some of the slides that we have coming up, we will be putting up polls. I'd just like to ask if you could please all participate. It's nothing it's more on a lighter note. John, if we could go to the next slide, please. So just to take you through our approach today, in the time that we have spent advising Vanitec on RFB, a big part of what we always do is to monitor what is being said in the media about energy storage, and to then subsequently understand how the VRFB features in those conversations. And this now is the structure of our presentation, that we will go through this conversation around how energy storage is perceived in the media by taking a look at how many articles have been put out to date about energy storage, and then measuring to what extent the VRFB features in this. And also in this, we've extended it to make it a comparison to see how does the VRFB compare to other type of flow batteries in these conversations. Then the next part of our presentation, we're going to looking at how the ESC has, through marketing, contributed to this visibility of the VRFB, and how we plan to continue doing that.
You ready for the first poll?
Yes, so before I continue, just want to run a really quick poll to gauge how users on this webinar now think how much coverage energy storage has received year to date, and of these conversations, to what extent has the VRFB featured in this. So the poll should be up on your screen now. It's just a matter of selecting either one of them. Perfect.
Another 15 seconds or so here, and then we'll release the poll results. All right, looks like we're about to the end here. I'm going to give it 5 more seconds, and then we're going to end the poll. All right, so here's the results.
Okay, so 55% of us on this webinar now believe that less than 100,000 articles have been put out year to date about energy storage, and 45% feel that more than 100,000 have been answered. John, if we could just go onto the next slide, in which we'll see on which side either of you are on, whether it's less or more. And from our year-to-date media analysis that we have conducted, we have seen that year-to-date 2020, there's been almost 180,000 articles that make mention of energy storage. And when we say they make mention of energy storage, it's not that the articles have been purely based on energy storage, but energy storage is becoming part of wider conversations, which is part of the mandate that we have as the Energy Storage Committee, is to have energy storage first being considered in conversations. And what we have also seen in our analysis is that a lot of the conversation here is closely linked to renewable energy, which is one of the main uses of the VRFB, as we know. And to the extent that we see that energy storage is being included in these conversations, then that points out that there is now then opportunity for the VRFB to be included in these conversations. Then, John, could we just go to the next slide? Now that we have a sense of how big the energy storage conversation has been had, what we then also wanted to see is to what extent is the VRFB included in these conversations. And from what we have seen is that though the VRFB does not dominate these conversations, we did a year-to-date analysis from 2019 to 2020. And the VRFB's growth rate in that energy storage conversation has been almost over 50%, which is more than all the other technologies that we have sampled here. As you can see on the slide, we've sampled the lithium-ion batteries, lead-acid batteries, and hydro energy storage batteries, all of which are included in this conversation. But in terms of the type of flow batteries, the VRFBs have been leading this in terms of the growth rate. And what this has then now indicated to us is that there is opportunity in the media for the VRFB to be spoken more about. But also what we're seeing here is that the work that we've been doing in the background in marketing the VRFB is being realized as we see it from the growth rate from 2019 year to date to 2020 year to date. And to sum this up, the focus has been around renewable energy. And the more renewable energy is being spoken about in relation to energy storage, we know that then there's opportunity for the VRFB to then be realized. And that is a big part of our marketing mandate, is to make sure that the VRFB forms part of these conversations. John, we can move on to the next slide. Now, moving into our marketing update. This is now building up from the visibility update that I just took you through, showing how the VRFB is, to what extent the VRFB is being covered in the media. Now we're going to look at, through the marketing initiatives that we have done, how has the Energy Storage Committee contributed to this, and how will we continue? But before we proceed, we'd like to run a second poll.
All right, here's the poll. I'll leave it open again for a minute. You could all please vote. Which of these statements are true for the VRFB in 2020? All right, I think we've about tapped out the numbers. I'll give it 5 more seconds.
Okay.
All right, here we go.
Okay, these are very, very interesting. And I think the true answer here is that all of the above applies. We know that one battery developer's battery will mark its 5th year anniversary, which is Sumitomo's battery. As part of our marketing strategy for the Energy Storage Committee, we've also deemed 2020 the elevating year of the VRFB. And through media coverage, we've also seen that there are a number of battery orders that are set to come online in 2020. So the results of this poll is that actually all of the statements above were true. And I hope that with the explanations I've given now, that those that didn't select all of the above will now understand why all of the above features. We can go to the next slide, John. And just to recap on our marketing initiatives and our marketing objectives for the ESC, when we started working in 2018 and 2019 on the marketing for the VRFB, the plan was to set a solid foundation through building and maintaining awareness. And now that we are in 2020, the plan for us was to now harness this awareness. And part of harnessing this awareness is also realizing just how far we have come in marketing, and that a good job has been done. And it is now time to really capitalize on this. And this is done through naming the year 2020 the elevating year of the VRFB, which forms the foundation of the work that we are doing to date for marketing. You can go to the next slide, John. So we have actively been working on managing Vanitec social media accounts. This is done on Twitter, LinkedIn, and on Facebook. And I think a lot of you that are on this webinar today probably follow our accounts, and you've seen that it has been our goal to keep an active and relevant feed that communicates relevant information about not only just about the Energy Storage Committee and the work it does, but about Vanitec as a whole and the vanadium industry. In relation to to marketing of the VRFB and the Energy Storage Committee. Majority of our posts in this year have been dedicated to that, which is part of our strategy. If we're saying that we're deeming this year the elevating year of the VRFB, we have made it our mandate that we need to put out as much information about that on social media, and we have continuously been doing that. What we have also seen is we try to measure the impact of our work in terms of marketing the VRFB through comparison of VRFB mentions on social media. So we know that mentions on social media range from mentioning the actual word VRFB or hashtagging it. We still have cases where the battery is still being referred to the vanadium battery or the vanadium flow battery. But now in consolidating all of that, what we have seen is that from at a 2020 year to date where we are now, the mentions of the VRFB have doubled from last year 2019's year to date. And that shows that through our strategy of continuously marketing the VRFB, but also making sure that we keep the social media content relevant has played a good role in making sure that the VRFB is mentioned in a lot of conversations on social media. Go to the next slide, please, John. Then this is just to show you an example of some of the content that we've been putting out. And what we always aim to achieve is to put out content around relevant topics at the time. So we know that there's a lot of conversation going on around leasing of the electrolytes. And so to the extent that we can, we have been putting out content in that. And also part of our aim is to position the VRFB as a sustainable technology, which we have done through our messaging on social media. Next slide, please, John.
All right, there we go.
It's okay. Then we have recently run a social media campaign to get an insight of what you, the VRFB audiences, would like to know about the technology. And part of this is for us as an industry to make sure that we know that we're putting out relevant content of information that you would like to know. But also this is an industry effort to make sure that the industry is above information, and that as Vanitec, we are your first stop to getting any information that is needed. It is our aim to work within the industry to work on creating a unified approach and answers to some of these questions. And these will be further discussed on the call with the developers, in which it would be a joint effort or joint collaboration in getting these answers out to the market. Next slide, please, John. We have also put together a VRFB timeline. And in our experience, we have seen that credibility is built through demonstrating the history of something, or rather demonstrating the journey a certain thing has traveled. And we all know of when the first patent of the VRFB has been commissioned and so forth. But between then and now, there's been a number of milestones that have been achieved within the market. And this is the aim that we wanted to achieve through this timeline, is to not only show the milestones, but to then position the VRFB as a proven technology. And how we plan to distribute this will be done on social media. And we'd also like to encourage, if people have any inputs in terms of milestones that you feel should be here on this sheet that are not here, we're open to such suggestions. Next slide, please, John. Then we have worked on animation concepts to illustrate the sustainability and practicality of the VRFB. The first one that we've done, and in the interest of time, I don't think we will play this first animation.
I think we have time for this.
Oh, do we? Okay, fantastic. Yeah. So I think, John, you can go right ahead and play. Thank you for that, John. And as I said, is that the purpose of the animation is to show the sustainable benefits of vanadium through the VRFB, which we have clearly illustrated. Can we move to the next slide? We've also worked on a second animation concept that also illustrates the practicality of using the VRFB in different industries and what the benefits around there is. So this is still an animation in progress, and we are going to still bring in the aspect of what the benefit of using the VRFB is. But John, if you could just please play this for us.
Yeah.
The vanadium redox flow battery, a sustainable and economically viable energy storage solution available for use across different industries. For utilities, the VRFB increases overall grid stability, which provides potential for significant revenue to be realized. For renewable energy, when there is abundant sun and wind, the VRFB is able to store this energy for later use. Because the VRFB suffers no degradation during ramping up and down, this saves costs. For the primary sector, the VRFB presents a cost-saving initiative by granting users the option to reduce their power demand at a time when premium fees are being charged. For power plants, the VRFB can be scaled up to serve as a black start solution to provide the power needed to return the plant to full service. For electric vehicles, the VRFB contributes to the reduction of carbon emissions by powering electric vehicle charging stations. For the telecommunications industry, the VRFB replaces high maintenance and hazardous battery systems used to stabilize grids that are connected to the towers. This, in turn, mitigates exposure to the effects of price fluctuations of fuel and maintenance costs.
Thank you for that, John. And as I said, that this video forms part of the bigger picture of industries realizing that the VRFB is helpful or can be beneficial rather for their industries. And our plan is that once we have concluded this concept is to be very targeted in our distribution. And this would include now targeting associations that are relevant to these industries that we have mentioned in here to highlight the core goal here, which is that the VRFB is practical and there are benefits to deploying this in their daily operations. Next slide, please, John.
You have a poll here. There's a typo in there. It should say which of these industries can benefit from the VRFB.
Yes. So this is just to see to what extent do we feel is the VRFB a solution provider? Is it relevant for some industries? Is it relevant for any industry?
Give this a few more seconds here for those to vote who haven't had a chance to vote yet. All right, I'm gonna end it there and share the results.
So yeah, so 75% majority of everyone who answered here is that the VRFB can work in all of the above industries, and that is very correct. I think the core thing for us to get an understanding of is that wherever there's a power source needed, the VRFB could most likely be useful there. So thank you for participating in that. Next slide, John, please. Then in response to conversations that we had last year in Lyon with the battery developers, we have worked together with the Energy Storage Committee in putting together this forum that will serve as a unifying approach for the industry to answer questions that the market might have. This forum is particularly only for VRFB developers, and we will be going more into detail on on the call that we have with the battery developers. Then you can go into the next slide, John, please. Then what we have also done in this year is that we have come in to update the Energy Storage Committee membership brochure. And what we have really done is make sure that we paint the whole picture of the benefits of being part of the Energy Storage Committee. So having a look at what you can receive as a promotional ad or research or marketing. And this is really a lot more relevant for the battery developers. But what we did was to also update the look and feel. We find that whenever something is more visually appealing, you're most likely to retain better attention in people reading it. So hopefully we have achieved that with this. Then last slide. Then just to close off our presentation, as I said, we will be continuing to produce marketing materials that will improve the visibility of the VRFB. And part of these initiatives is with ongoing social media. We're looking to put out a press release in the coming few months. We're also looking to support the ESC with, once the white paper has been fully concluded, we're looking to put out marketing material that will easily break down the results or findings from the white paper. What we're also moving into doing is to introducing a podcast. And this really, the aim here is to have a voice behind the Energy Storage Committee. And in the coming months, we'll have a podcast that is focused on the VRFB. And what we will also incorporate in this podcast is some of the questions that we get from the social media Q&A that we've run, and also some that are from the forum that we can answer within Vanitec's antitrust. Then just to end off, as I said, we're always looking for new ideas, new ways to engage with our audiences, and we'd appreciate it if based on what we've presented today, if there are any suggestions or new ideas that you feel we could implement in advancing the VRFB, we'd be more than grateful to receive that. And I think that sums up our presentation. And thank you all for listening.
Thank you, Suelo. Yeah, we have a few questions and comments. The first one, I love the fact sheet. Maybe an idea to also link the open access papers that support the fact sheet, hyperlinked. The aim would to make it to be the reference for people who start a paper on the VRFB. So that's a good comment for us on the fact sheet.
Yes.
The second one,
Very
and the
good.
next two questions actually came in about the first video. Is the film available for everyone, and is it available in YouTube?
Yes, if all of our marketing materials are put up on our social media channels. If you want to download the videos, they are available on YouTube. Alternatively, you can send us a message on either of our social media platforms and send you a direct link to download any of our marketing materials.
Great. Next one. Have you considered putting up case studies on existing batteries to provide real data and demonstrate that there are working installations for those who don't realize there are working installations?
Yes, one of our strategies for the year is to focus on VRFB success stories. We had already started this last year with the VRFB map, show installations around the world. But as we proceed in this year, we have a more targeted approach in sharing information on installations. But what we also would like then to encourage us for information sharing. If any of you on this webinar now have any information about upcoming installations, would be more than willing to receive that and distribute it on our social media channels.
Great, thank you. Let me just run through the questions here, see if there's anything else. Yes, well, this is actually one for me. Are you open to new memberships for startups? Absolutely. We have a separate category for startups who want to join. So please contact me at vanitec.org, john.hilbert@vanitec.org, and I can respond to you directly and get you a membership application. Are there any other questions? If you have questions, please put them into the Q&A. I got some, here we go. A lot of energy system modelers are using very out-of-date information on the VRFB technology. Would it be possible for the Vanitec ESC to produce a state-of-the-art article based on up-to-date information collected from VRFB manufacturers to include the following parameters: CapEx per kilowatt, CapEx per kilowatt per hour, round-trip efficiency, and the number of operational cycles? I think we'll take that up as the Energy Storage Committee and discuss that in the next call we have. We have a monthly call for those who aren't members, and these are just the sorts of things we talk about in terms of our next projects. So we'll see if we can get that included in our agenda for the future. Any other questions for Suella? All right, thank you, Suella, I appreciate that.
Thank you, everyone.
And again, if you haven't already yet, please follow us on Twitter and on Facebook and all of our channels. So I just want to end with a couple of comments, and then I'll turn it over to our chairman, Mikhail, to comment as well. Our upcoming activities for the Vanitec Energy Storage Committee, we have our web developers call taking place right after this in about 12 minutes from now. For those of you on the call who are taking part and who've been invited to that call, note that it is a separate login. It's not part of this webinar, so you have a different link to go into for that developers call. We'll be sending out a feedback form to all of you next week to give us your feedback on this webinar today. The 8th Vanitec ESC meeting is only for members. That will take place this fall in conjunction with our overall meeting. As you can all imagine, given coronavirus, we're not sure if that meeting will be in person or probably likely as another Zoom call for our members. And then our 9th ESC meeting, open to the public, will take place next year in coordination with the IFBF meeting. And I have asked Anthony Price if he'd like to say a bit about the IFBF, both what's coming up here this year and next year. Anthony, are you there? And I've opened you up to talk. Can you speak, Anthony? All right. So I guess he's not on right now. The IFBF is hosting a forum tomorrow and Wednesday online. And hello, Anthony.
Hi, sorry about that. Just calls on Zoom all over the world.
It's okay.
John.
You want to say something quickly about IFBF's plans this year and next?
Yes, certainly. So tomorrow and Wednesday, the IFBF will be meeting virtually. We've got 2 sessions, 2 tomorrow, 2 on Wednesday. One's covering policy, one's covering supply and ramp up to meet demand from a digital economy on Tuesday. Wednesday, we're looking at other applications for flow batteries and flow battery technologies. Our plans, of course, have been a little bit disrupted. We should have been meeting in Germany. We would have been having a party of all parties down by the Bank of the Rhine this week. That, of course, hasn't happened, but we've arranged for the IFBF to be postponed and to be held next January, we hope. 3-day session back in Düsseldorf, and we're still considering what form a meeting might take in the summer. There's a lot of interest in us hosting a meeting in the summer months. People like to gather together and it keeps the cycle going. And we're looking perhaps at a place in Oxford, not least because there's a flow battery going in just around the corner from where the conference venue might be, which would give us a chance to go and have a look at it. But we hope very soon to get back to our normal routine of an annual conference and a close association with Vanitec. So I hope, John, that's helpful for you.
That's great. Yeah. Thank you very much, Anthony. All right. So then I'll just turn it over to our chairman, Mikhail, for any final comments you have, Mikhail, on the webinar today.
Thanks, John. No specific comments. This was a great experiment. I think a successful one. So we're going to take some learnings from it. If we can get some more feedback from from our feedback forms that we will send around, that would be great. We're learning. Maybe we'll figure out a way to combine both in-person and in video versions going forward. I'm hoping this was still extremely helpful, and certainly if we can get the feedback and guidance on what we can do to improve and what we can continue to do as we've been doing, that's great. Again, the focus of the ESC is to just increase the communication information exchange on vanadium, specifically within the energy storage industry. And I think this is kind of another step in continuing that support for the industry. So that's it from my side, John.
Great. I appreciate everyone being here today. Stay safe, everyone, please. And we hope to see you in person next year. Thank you.